Hello, good evening to all of you. I hope all of you are doing well. So, in today's class, we're going to discuss about white box testing. Now, white box testing is a test case design mechanism that aims at designing test cases taking into consideration the internal implementation of a given system. Right now, there are different forms of white box testing. These are called as statement coverage. We have branch coverage, we have condition coverage, and we have path coverage, right? Now, statement coverage basically aims at executing each and every executable statement that a programming construct has, right? So here what we tend to do is we tend to inflate the program with a number of print statements that are capable of printing the values of the various variables that are to be tracked. Now, this is a very brute force approach where what we tend to do is we tend to execute each and every statement and see the way how the program is capable of delivering the said result, right? Now, in case of branch coverage, what we tend to do is we tend to uh, execute each and every branch that is there in the programming construct. So branch by branch here, basically what I am trying to refer to is I'm trying to refer to any of the conditional statements. So for example, if there is a programming construct like if A is greater than B, right? So what we do is we assign value to the branching statement. So a greater than b is assigned either true or false, right? And we'll try to determine the course of execution. Now, in case of branch coverage, irrespective of whether the condition that is there in the branch is simple or complex. For example, a greater than b is a simple statement, right? Simple condition. If I consider a is greater than b and a is greater than c, then it's a complex condition. So, irrespective of whether it's a simple condition or a complex condition, in case of branch coverage, a boolean true or false is assigned to that particular condition and the path of execution is determined. That means here in case of branch coverage, what we do not do is we do not take into consideration individual conditions. Instead, we take into consideration the entire branch and the entire condition and assign boolean true or false and determine the course of execution. So in case of statement coverage, we tend to execute each and every statement that is there in the programming construct. In case of branch coverage, we tend to assign boolean true or false to each and every branching statement, irrespective of whether it's a simple condition or a complex condition. Now, in case of condition coverage, what we tend to do is we tend to assign Boolean true or false to the individual conditions in the branch. So, an example, if it's written as if A is greater than B and A is greater than C, then to both the conditions A is greater than B and A is greater than C, what we do is we assign Boolean true or false and we determine the course of execution. That implies in case of condition coverage, if there are n number of conditions, then we need to execute the programming construct for 2 to the power n number of times, right? So because if there are n conditions, so it's a binary system, right? So we need to execute it for 2 to the power n number of times. So if there are two conditions, we need to execute it for 2 to the power 2 number of times. That is 4 times. If there are three conditions, we need to execute it for 2 to the power 3 number of times. So we need to execute it for 8 number of times, right? So depending upon the number of conditions, what we tend to do is we tend to decide upon the number of executions, right? So it will be always 2 to the power n. Now, in case of path coverage, what we tend to do is we tend to execute each and every path that exists in the programming construct. So here by path, what I'm trying to imply to is I'm trying to imply to linear independent path. So in case of path coverage, we tend to execute each and every linear independent path that exists in the programming construct. Right now, what is a linear independent path? A linear independent path is a path that introduces at least one new edge, right? Again, so a path in the graph that introduces at least one new edge is called as a linear independent path. So in case of path coverage, we tend to execute each and every path. So till now, what we have learned is we have learned what is white box testing. So we have learned that white box testing is a test case design scheme that tries to take into consideration the internal implementation. And there are four types. One is called as branch coverage, the other one is called as condition coverage, the third one is called as statement coverage, and the fourth one is called as path coverage. Now, these details are not provided in the presentation because I want you to prepare an assignment on it, right? Okay, and on a concept that is called as McCabe psychometric complexity, right? Okay, so McCabe psychometric complexity is a complexity that tries to represent the structural aspect of the system, or it focuses on the structural complexity, right? So you need to prepare an assignment on the various white box test case design mechanism and McCabe psychometric complexity, right? So now let's try to move on different types of testing that we have in a software system, right? Okay, so there are three types of testing as we have learned about. We have unit testing, we have integration testing, and we have system testing. Now, in case of unit testing, a module is tested in isolation, where the ability of the module to deliver the result is tested. So, in case of unit testing, we will check for the integrity of the module or the ability of the module to deliver the expected result. So, as we have learned, in case of integration testing, what we need to do is we need to create a test environment that contains driver and stub. So driver invokes the module under test, the module under test invokes the stub, and the driver is also responsible for providing access to any non-local data structure that the module under test requires. So once the module has been unit tested, then what we can progress on with this, we can progress on with integration testing, where what we tend to do is we tend to integrate the unit tested modules and check for its ability to interface with one another, right? So that's why it's also called as integration testing, right? And unit testing is also called as functional testing, right? So then once it is unit tested and integration testing is performed, then we go on for system testing, where we learn that there are three types of system testing. These are alpha, beta, and acceptance. Alpha is done by members of the development team. Beta is done by the members of the friendly organization, and acceptance is done by the members of the customer organization to decide whether or not to accept the software system or not. So unit testing, as I've said, is a testing of module isolation, where we need to prepare the test environment and which has a driver and a stub. Okay, so the reason why we need to have unit testing is because it will be very easy for one to detect error in situation where it exhibits error, because the search space will be very less. So if we integrate a set of modules and perform unit testing, then it would be very or perform testing, then the search space would be the entire integration, resulting in greater amount of effort required for detecting error. So debugging becomes very difficult, right? So that's the reason why we need unit testing. Now we've learned integration testing is a kind of testing where we check for the interfacing ability of the modules, right? Whether the modules are capable of interfacing with each other or not, or interacting with each other or not, in order to realize the business. Then we talked about system testing, where what we do is we check for the correctness of the system, right? So now let us move on to integration testing and learn about some of the integration approaches, right? Now, first one is called as Big Bang integration or Big Bang approach, where all the modules are taken into account and integrated in a single step. So it's a single step integration. But one of the major problem with Big Bang integration is that if there exists error, then the search space will be the entire program, right? Again, so although it's very simple and easy to implement, but in situation if uh, it exhibits error, then the search space will be the entire program. Top-down approach. In case of top-down approach, what we tend to do is we tend to prioritize the module based on their relevance to the existence of the system, and then over a series of integration, what we tend to do is we tend to integrate the modules, right? A bottom-up approach, we tend to group the modules based on the type of activity it performs, and then we integrate the subsystems in order to create new system. So mixed mode approach where what we tend to do is we tend to adapt to either either top down or bottom up, depending upon the requirement of the integration. So let us talk about Big Bang integration. So it's a very simple approach where all the modules are integrated in a single step. But the problem is that in such situation, if the system exhibits a an error, then the search space for the error will be the entire program, right? Okay, so the error may potentially belong to any module belonging to may belong to any of the modules that are there in the system. So it's applicable to only situation where the problem size is very small, right? Now, bottom-up approach. In case of bottom-up approach, what we tend to do is we tend to identify the modules based on their behavior, based on the behavior they exhibit, group the modules based on the similarity of the behavior, and group the subsystems in order to create the partial system over a series of integration. Now, disadvantage, when the system is made up of large number of smaller subsystems, then it may take a huge amount of time uh, for executing a bottom-up integration. Now, in case of top-down integration, what we tend to do is we tend to start with the main routine and then select few of the routines, and over a series of integration we complete the system by taking the new set of routines. So here, in case of top-down integration, it's very important for us to prioritize the modules, and over a series of integration what we tend to do is we integrate modules having similar priority. Now, in case of mixed mode approach, what we tend to do is we tend to adapt to either a top-down or bottom-up approach based on the requirement of the integration. Now, let us talk about system testing. So, we've learned about there are three types of system testing. One is called as alpha, beta, and the other one is called as beta, and the third one is called as acceptance testing. Now, alpha testing is the testing that is done by the members of the development team. Beta testing is the testing that is done by the members of the friendly organization, and acceptance testing is the testing that's done by the members of the client organization to decide upon whether or not to accept the software system. Now, till now, what we have discussed about is we have discussed about different types of testing, but we need to know that the basis for all the testing will be the SRS document that was agreed upon by the developer and the customer. So, as the specification document is always taken into confidence whenever testing is carried out. Now, let us talk about an important aspect that is called as error seeding. So, error seeding is the mechanism of planting the errors into the software system, right? In order to determine the capabilities of the test cases to determine the planted errors, right? So here, let capital N be the total number of errors that may be there in the system. Again, I'll repeat it. So error seeding is a mechanism of planting errors in the software system and determining the capabilities of the test cases that we have designed to determine the planted errors, right? Okay. Now let capital N be the total number of errors that may be there in the program. Small n be the number of detected errors. Capital S be the total number of seeded errors, and small s be the total number of seeded errors that are determined. So capital N, total number of errors, small n, total number of errors detected, capital S, total number of seeded errors, and small s, total number of seeded errors detected. So if I have to create a relationship, right? So what we have is we have small n by capital N is equals to small s by capital S. So we're just creating a proportion. So now what we can see is we can say that by performing cross multiplication, we can say that capital N is equals to capital S into small n by small s, right? And then the remaining defect. So if I substitute n from here from both the sides, so what I have is n minus capital N minus n, is the remaining number of errors. So n minus n can be represented in this particular form. Okay, as you see, or using this particular notation here. So here what I have given is I have given a very simple example for error seeding, right? Now let us try to understand what is debugging. Now debugging is the process of determining the point of origination of the error and bringing about a rectification or initiating a rectification procedure. Now debugging and testing is not similar. The objective of testing is to detect error. The objective of debugging is to correct error. So debugging aims at correcting error, whereas testing aims at detecting errors. So there are different reasons why what we need to do is we need to perform debugging. And there are different types of debugging. So once an error has been detected during testing, then what we need to do is from the point of detection, what we need to do is we need to go back to point of origination, and then we need to bring about necessary changes in that particular statement as well as all the statement that precedes that in order to ensure that the program is not capable of exhibiting error from that particular point onwards. So once an error is identified, it is necessary to identify the precise location of the error and fix them. So each debugging approach has its own advantage and disadvantage. So this we will discuss about. Now there are different types of debugging approach. The first one is called as brute force approach. The second one is called as a cause elimination. Third one is called as backtracking, and fourth one is called as program slicing. So there are four different types of approaches that you can have. The first one is called as brute force approach. The second one is called as cause elimination, third one is called as backtracking, and the fourth one is called as program slicing. Now, in case of brute force approach, what we normally do is we execute each and every statement and see and then try to locate the position of the error, right? So in case of brute force approach, what we tend to do is we tend to load the program with n number of print statements, and by examining the values that are printed, what we tend to do is we tend to determine the location of the program, right? Now in case of backtracking, now once the effect of the error is being observed, right? So once the effect of the error is being observed, then what we tend to do is we tend to backtrack till the point of origination. So once the point of origination is reached, then what we tend to do is we tend to bring about a corrective action, and then again in all the subsequent statement preceding that, what we'll do is we will bring about a change. So backtracking is basically a mechanism of moving back from the point of detection to the point of origination. Now, cause elimination. So, in case of cause elimination method, what we tend to do is we tend to identify all possible causes that may lead to an error. Right? We tend to identify all possible causes that may lead to an error. So, once the list of causes are identified, then what we tend to do is we tend to take into consideration each of the causes and see whether the cause has actually led to the error or not, right? Okay, so in case of cause elimination method, we tend to identify all possible causes, and then we will select a particular cause and see whether it's the responsibility of a given cause for that particular error, and in over a series of steps we'll try to actually eliminate all the causes and see whether these causes are the causes that are actually causing the problem or actually leading to the error. Now, the fourth one is called as program slicing. Now, program slicing is a mechanism where we try to divide the overall program into slices. That means we tend to partition the program into smaller subsection, and what we tend to do is then we tend to carry out backtracking, right? So here what we normally it's kind of evolution to the backtracking approach, where in case of program slicing, we reduce the size of the search space. So these are the four debugging methods that we have. So we have brute force approach, we have cause elimination, we have backtracking, and we have program slicing. So in today's class, what we have learned about is we have learned about what's white box testing, right? Again, we have learned about what are the different types of white box testing. We have learned about what are the different types of white box testing. So we have learned that there are four types of white box testing. These are statement coverage, branch coverage, condition coverage, and path coverage. Right? Again, we learned about description of each of this, and I've asked you to perform an assignment on all of these types of uh, test case design schemes, and I have also asked you to prepare an assignment on McCabe's psychometric complexity that will give you the structural complexity of the software system. And then we try to discuss different types of testing, where we have integration system and unit testing, integration testing, and system testing. We discussed about the attributes of each of the testing mechanism, right? Again, we discussed about what is unit testing, how is it done, and what is its significance. We talked about integration testing, how it is done, and what are the significance. Then we talked about system testing and what are different types of system testing. Also, we have discussed. Then we discussed error seeding. Okay, we discussed error seeding, where we try to determine the errors that are there in a particular programming construct, and then we moved on to debugging, where we discussed the different types of debugging and importance of debugging. So this ends the testing chapter. So I hope all of you uh, are well, and please do stay safe, and please do perform the assignment. Thank you very much.